Let's take a look at the first one. We want to factor by grouping. So the question clearly telling you, hey, we need to do that by grouping. Indeed, if you take a look at this expression, you have four terms, and they are all unlike. We cannot combine the like term. So even though they don't say factor by grouping, and seems like that is the only way that we can handle the problem. So let's see what are we going to do. We will group the first two terms together, and then we will group the last two terms together. Now remember, when you group the last two terms together, when you put the parentheses around the last two terms, it must be after the operator, after the plus sign. Don't put the open parenthesis before the plus. Otherwise, you will make it becomes two binomial times together. Even though later on you get the right answer somehow, that would be even worse. Because then in the future you will make mistake. When you see two binomial times together, you will do something crazy. So remember, the process is absolutely important. From the first group, do we have anything in common? Y is in common. So we factor out the Y. Once we factor out the Y, we will have x plus 5 left over. Now we should know how to get the left over clearly. The original terms divided by the GCF. That is how we get the x. Original terms, 5y divided by y. That is how we get the 5. Plus, from the second group, what can we factor out? 6 can be factored out. So the leftover will be x plus 5. Now, if I take a look at these two terms, both has x plus 5. So we can further factor out the x plus 5. So we will have x plus 5 times y plus 6. And that is how we handle this problem by grouping. We need to factor by grouping. So we take a look at these four terms. Once again, even though they don't say factor by grouping, you have four terms and they are all unlike. So you will probably need to use it by grouping. And we will group the first two terms together, and then we will group the last two terms together. And remember, when we group the last two terms together, the open parenthesis must be after the operator. So far, so good? Yes? Very good. We must change the sign this time. This is something special. On the third term, we see the minus. So immediately, we need to change the sign when we put the parenthesis around the last two terms. You don't change the sign later on. You don't change the sign when it doesn't work, so you make it works. It's not like that. Once you have a minus on the third term and you group the last two terms together, we must change the sign. And then continue. Let's take a look at the first group. Do we have anything in common? Y squared is in common. So we have the A plus 5B left. Minus, from the second group, we have the 2x left. I mean the 2x as the common factor. So we factor out the 2x, and then we will have the A plus 5B. Now, not because in the first one we have the A plus 5B, then the second group must have A plus 5B. You really need to work it out and see if they are the same. If they are not the same, you cannot continue to factor. We have two terms, and both of them has A plus 5B as a common factor. So we further factor out the a plus 5b. So the leftover will be y squared minus 2x. Let's see number 3. We have two terms. And what can we do if we want to factor out these two terms? The very first thing we need to do is check it out and see if they have anything in common. That should be the very first step in all kind of factoring. So we have x in common. I'm going to factor out the x, and then the leftover will be 216 plus x cubed. Can I do more? Yes. We have two terms add together. Well, we do not have a squared plus b squared situation. We cannot factor out a squared plus b squared. But we can factor out the a cubed plus b cubed. Indeed, the question giving you a big hint, telling you to use the formula for the sum or the difference of two cubes. So you must know those two formula. If you don't know, then it's hard for you to move on. A cubed plus B cubed, what would that equals to? A what? Plus B. Now help yourself to try to remember the formula. Don't wait until the last day, kind of take a peek and then see, oh, that's the formula. You will not remember that. So start remember during the semester. A plus B times what? A squared minus AB plus B squared. Would I be able to make the 216 plus x cubed becomes the sum of two perfect cube? X cubed is already a perfect cube. How about the 216? Would that be something cube? What would that be? If you don't remember the perfect cube list, well, your dancing shoe would be very helpful. Anyone? It would be 5, 6, 6 cube plus x cube. Okay. So we will have a equal to 6 and b equals to x. Some would like to have the x go first. That is absolutely fine. We can flip them around. We can make it becomes x times x cubed plus 6 cubed. That is perfectly okay. Now, as you can see from the formula, if you flip the a and the b around, it doesn't make any difference because the addition has the commutative property. So if you like to let a be x, b be x, or if you let a be x and b be 6, that is perfectly okay. So now, well, but the x in the beginning, in the front, the factor, this x is definitely important. Sometimes some students just focusing on whatever inside the parenthesis, and then later on put down the x. That is a very scary move. You should always put down anything you are not working on. Just continue, make them equal. They are equal to each other. So now let's apply the formula. I have the a equal x, b equal to 6. So what would that becomes? I still have an x in the front, x times x plus 6 instead of a plus b times x squared minus x times 6 plus 6 squared. Replace a and b by the corresponding variable or number. we can simplify a little bit more. That would become x times x plus 6 times x squared minus 6x plus 36. So that would be our final answer. Okay. Let's put them in a box. Okay. Let's take a look at number 4. We have x to the 6 minus 343y cubed. So this time, this is the difference of two terms. So if the question did not give us any hints, we would think about what kind of special product formula we have. We have the difference of two perfect square. X to the 6, we can make it becomes a perfect square. But the second term, we got y cubed. Definitely we cannot make it becomes a perfect square. We can make it becomes the difference of two perfect cube, maybe. Do we remember the perfect cube formula? A cube minus b cube. What would that becomes? A minus b times a squared plus ab plus c squared. So now let's see if I can turn them into the difference of two perfect cube. X to the 6 will be what cube? It would be, what would that be? Something cube. How can I turn x to the 6 become something cube? That would be x squared. Okay. Because we have a raise it to the m, raise it to the n power, that would becomes a raise it to the m times n. So now we are going backward. Minus, well, y cube is already a perfect cube. That's good. How about 343? That would be 7 cube. So it would be 7y in parentheses cube. So now, can we tell what would be my a? X squared. What is my b? 7y. So now we place the a and the b by the corresponding number and variable. So what do we get? We will have x squared minus 7y times, open parenthesis, x squared plus x squared times 7y plus 7y squared, close the parenthesis. Okay. Now note that which one is the a? A is x squared. Which one is the b? The b is 7y. So we apply this into the formula. We replace the a by x squared, replace b by 7y, and then we will do the same thing for the second parenthesis, and that is why we have this. Yes? Well, the difference of two perfect cube is on the instruction. It's telling you to use the sum or the difference of two perfect cube. So let's continue. Let's simplify that because we can. So that would become x squared minus 7y times, open parenthesis, x squared squared. That would become x to the 4. How do I get the 4? Is that because 2 plus 2? It's because 2 times 2 plus 7x squared y, because we like to put the x before y, plus 7y in parentheses squared. So we have 49y squared like this. See number 5. We have a complex fraction. We have a fraction within a fraction. So what do we suppose to do? We need to identify what would be the LCD within this complex fraction. So what are we considering? The LCD of x, 3, and 6. So it would be 6x. Very good. So once we identify the LCD, we are going to multiply both top and bottom by the LCD. So we multiply this by 6x. We multiply this by 6x. Now don't put the 6x in the middle and assuming, oh, I times 6x, that means I times both top and bottom. That would be a wrong approach. Even though later on in your mind you know, oh, I have a 6x times the numerator, I have 6x times the denominator. That would be wrong, as we mentioned before. So now let's distribute the 6x into the numerator. Don't just cancel out something right on the spot. We have 4 times 6x plus 2 over x times 6x. And then the whole thing divided by x over 3 times 6x plus 1 over 6 times 6x. Once we do that, let's see what happens. 4 times 6x, 24x, plus 2 over x. X cancel out, right? So we have 12 over, in the denominator, 3 go into 6 2 times. So you have x times 2x, you have 2x squared, plus x cancel out. So 1 times x, it would be just x. You see that in one step, we will get rid of the complex fraction. No more fraction within a fraction. So let's continue to simplify this simple fraction. I have the 24 on the top, I have a 2 in the bottom. Can I reduce them? Can I say 2 go into 24 12 times? No, we cannot. We have a plus in between. It's the whole numerator divided by the whole denominator. So how can I simplify that? I need to factor at the top. What can go into both terms? 12. So the leftover would be 2x plus 1 over, in the bottom. Let's see what happened. What do they have in common? X would be in common. So we factor out the x. So what is the leftover? 2x plus 1. Can we simplify anything? Yes, both top and bottom have 2x plus 1. So we can cancel out this. So we have 12 over x. Is that all? Don't forget to put down the condition. What is the condition here? Can x be anything? Not quite. X cannot be negative 1 over 2. Where do I get that from? If you don't remember, well, put the notes on the side. Why? Because when we reduce the 2x plus 1, we assume this cannot be 0. We cannot divide by 0. And then minus 1 on both sides and divide both sides by 2. That is how we get the condition. Let's see the next one. Number 6, we have a complex fraction again. So let's identify the LCD. What would be the LCD this time? That would be 7R minus 1. There's only one denominator there. So I'm going to times both top and bottom by 7R minus 1 times 7R minus 1 times 7R minus 1. Now it's necessary to have the parentheses. So what would that become? We have the 8 over 7R minus 1 times 7R minus 1, and then minus 8 times 7R minus 1. We need a parenthesis. Don't omit that parenthesis. And then the whole thing divided by 8 over 7R minus 1 times 7R minus 1 plus 8 times 7R minus 1. So let's see what happened. The 7R minus 1 cancel out here. So we have 8 minus 8 times 7R minus 1. The whole thing over 7R minus 1 cancel out again. So you got 8 plus 8 times 7R minus 1. Now some probably will distribute the 8 right away. That's okay if you feel comfortable, but be very careful. Don't make any careless mistake. Distribute the 8, so that will give you 56R plus 8. Remember, you distribute the negative 8 over 8 plus 56R minus 8. So that would becomes 16 minus 56R over 56R. Can I say the 56R cancel out? We cannot. We have 16 minus. So it's the whole thing together divided by 56R. But can we simplify more? Yes, we can factor out the 8 from the top. So we have 2 minus 7R over 56R. And now the 8 and the 56 can be reduced. So finally, you will have 2 minus 7R over 7R. Do we have any condition? Yes. The R cannot be what? 1 over 7. Because at some point, we cancel out the 7R minus 1. So we will assume, let me put it here, right? We assume that the 7R minus 1 cannot be 0. And that is how we got the condition. Okay. Now, indeed, if you go back to the previous one, if you go back a little bit, hey, at some point we cancel out the x also, isn't it? If we cancel out the x over here, don't we supposed to say x cannot be 0? Yes, we're supposed to. But why we don't bother to write down x cannot be 0? Because we still have an x down in the denominator. So in that case, it allows us to be a little bit lazy, because once people look at that 12 over x, they know x cannot be 0. All right, let's continue. Let's take a look at number 7. This is an equation involving fraction. We don't like fraction. So what are we supposed to do? Is there any way that we can get rid of the fraction? We are going to take a look at the what? The LCD. What is the LCD? LCD of A and 4, what would that be? 4A. So we are going to multiply both sides by the 4A. We cannot suddenly times something by 4A, but luckily we got an equation. So we can say, oh, let me multiply both sides by 4A. So we have 4A multiply the left-hand side equals to 4A multiply the right-hand side. On the left-hand side, we have two terms. So we are going to distribute the 4A. Right? Don't cross out anything at this point. You need to distribute the 4A. To make it like this. And when we practice more, some feel comfortable, they will merge these two steps together. So have 4A times every single terms on the left-hand side, and have 4A times every single terms on the right-hand side. Now let's continue to simplify. So we have the A cancel out, and then the second term, we have the 4 cancel out, and then on the right-hand side, we have the A cancel out. So what would that becomes? I have 4 times 5, that would becomes 20 minus A plus A times 3, 3A equals to 4 times 7, 28. Is that right? Everybody happy? If you're happy, then I'm not. What's wrong? Something wrong already. You distribute the 4 into the whole numerator. In the numerator, you have an invisible parenthesis around them. It's not just 4 times 5. It's 4 times parenthesis 5 minus 8. So you need to distribute the 4 into the numerator. So what do we supposed to have? 20 minus 4A. So we need to put the 4 over there, missing 4 here. So now let's continue. We have a linear equation, simple equation, and we can find what is the A. And we have 20 minus what? Minus 4A plus 3A. Would that be minus 7A? It would be minus A, which is equals to 28. Okay. I would add A on both sides and minus 28 on both sides. So I got 20 minus 28 equals to A. So I have a negative 8 is equal to A. That means A is equal to negative 8. Now it's absolutely fine to have the variable on the right-hand side for whatever reason. Try to keep the variable positive. It will save you from a lot of trouble. Take a look at number 8. We have equation involving a fraction. So we take a look at the LCD. What would be the LCD? the LCD of y plus 5, y minus 5, and y squared minus 25. So what would that be? That would be y plus 5 times y minus 5. That means it's y squared minus 25. Now, of course, you do need to know the special factoring and the special product so you can identify when we have the y plus 5 times y minus 5, indeed, that would be y squared minus 5 squared. So now I'm going to multiply both sides by the LCD. So we have the y plus 5 times y minus 5 times the first term minus the y plus 5 times y minus 5 times 3 over y minus 5, which is equals to y plus 5 times y minus 5 times 12 over y squared minus 25. I merge two steps together. I distribute the LCD onto the left-hand side immediately. So now anything we can cancel out, y plus 5 cancel out, the y minus 5 cancel out. On the right-hand side, the y squared minus 25 cancel out both of this. So what would be the leftover? It would be 6 times y minus 5. And if you feel comfortable, distribute it right away. But be careful, it's 6 times the whole thing. So it would become 6y minus 30, and then minus, and distribute the 3. So we got the 3y plus 15 equals to 12. Is that right? What's wrong? You shake your head. What's wrong? Now be very careful. The first one, 6 distribute onto the y minus 5. Yes, indeed, they are together. So we have a parenthesis around them. But that parenthesis is insignificant. But then when 3 distribute onto the y plus 5, we actually have a parenthesis around them. We have an invisible parenthesis, but now becomes visible. If you don't, oops, what happened? Okay, if you don't bother to have the parenthesis, some do that. If that is the case, then, oops, it doesn't work. If that's the case, then you must change sign immediately. Now that is a very, very common mistake, very easy to make. Remember, if this is minus, right? If over here, this is a minus, be extremely careful. Okay? Don't just, distribute the 3 and then everything stay the same. You have to change sign. Or it would be prudent to put the parenthesis around the first one here and put the parenthesis around the next one, and then next step you change the sign, and that would be nice. Yes. Yes, you can look at that way. So continue. That would becomes 3y minus 45 equals to 12. Add 45 on both sides. Then it continue. Then you got 3y is equal to 57. Divide both sides by 3. We got y is equals to 19. All right, so far so good. Let's take a look at number 9. We want to rationalize the denominator. Indeed, we should not leave the denominator having a radical form. So whenever you see something like that, you should do something to try to get rid of the radical in the denominator. What can I do so that I can rationalize the denominator? We will multiply both top and bottom by what? 5 plus radical 3 over 5 plus radical 3. Now that is what we call what is the name for that? Start with a C. Conjugate. Okay. So let's see what happened. On the top, I have 3 times 5 plus radical 3 over, in the bottom, what would that become? Well, why do we want to times it by the conjugate? Is because we are relying on the special product a plus b times a minus b. That would give you a squared minus b squared. So what happened? This would become 5 squared minus the radical 3 squared. So let's continue. That would be 3 times 5 plus radical 3, the whole thing over 25 minus 3. So that becomes 3 times 5 plus radical 3. Yeah, this should be a plus, right? Yeah. Oops. That's a little weird. Okay. Over 22. All right. Next one. How can I get rid of the radical in the denominator? We will multiply both top and bottom by the conjugate. What do you mean the opposite? It's supposed to be what? I'm looking for the conjugate of the denominator. What is that supposed to be? It's 10 minus radical 3. It's not a plus. Now be careful. The conjugate, if you have a plus b, the conjugate would be what? A minus b. If you have the a minus b, what would be the conjugate? The conjugate would be a plus b. That is the conjugate. But that is not the opposite. So be careful. Use the proper terminology. So did we make a mistake here? Yes, this is not a plus. It's supposed to be minus. All right? So that we can create a situation, we can use the special product formula. So now, let's see what happened. On the bottom, it will becomes 10 square minus radical 3 square. But what about the top? Now do not foil that. That makes you look bad. We should know the special product formula. This is indeed a minus b square. So we know this would becomes a square, that is 10 square, minus 2 times 10 times radical 3 plus radical 3 square. Well, it's a little bit long, the numerator, so I need to extend this a little bit. Otherwise, the radical 3 will start crying, right? Continue to simplify. 100 minus 20 radical 3 plus 3 over 100 minus 3. So that becomes 103 minus 20 radical 3, and then the whole thing divided by 97. Can we simplify? We should check it out. And the whole numerator, right? So I divided by 97. So I cannot just say, oh, let me reduce these two, reduce this two. Can we factor out something on the top? We cannot. So that means this will be the final answer. Everybody happy?